The Voyager 1 spacecraft from NASA is the farthest-traveling spacecraft ever launched. It continues its breathtaking journey across the universe. For nearly 50 years, Voyager 1 has been sending back crucial information from the farthest reaches of space, significantly advancing our comprehension of the cosmos. However, recent transmissions from this remarkable spacecraft have presented perplexing signals that have left the entire space community in a state of awe and bewilderment. These signals have sparked discussions about whether they are the result of a technical issue, or if they might be a sign of something far more extraordinary, such as extraterrestrial life. Join us on our journey as we delve deeper into the mystery surrounding these extraordinary transmissions and uncover what might be lurking in space's darkest corners. Humanity's fascination with the mysteries beyond our planet has been a driving force in space exploration since its inception. This insatiable curiosity led to the historic launch of missions like Explorer 1 and Explorer 2, which were among the most ambitious endeavors of their time. The launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just 14 days later, on September 5, Explorer 1 followed, setting the stage for a first-of-its-kind journey. These twin spacecraft, each weighing approximately 720 kilograms, roughly the size of a small car, were launched during an unusual outer alignment of planets, which had a significant impact on their trajectories and mission outcomes. Throughout their remarkable odyssey, these spacecraft traveled in divergent directions and at varying speeds. A defining event occurred on December 15, 1977, when Explorer 1 surpassed its twin due to differences in their paths. Consequently, Voyager 1 has emerged as a crucial asset, providing invaluable information that has revolutionized our understanding of the universe and its myriad phenomena. Before we dive into Voyager 1's latest astonishing discovery, which has captured the attention of the entire space community, let's revisit some of its most remarkable achievements. In 1978, during its Jovian imaging mission, Voyager 1 was about 265 million kilometers from Earth. By January 1979, it had begun an exceptional mission, capturing a captivating time-lapse video of Jupiter's rotation. This series of 3,750 photos attracted unprecedented attention, revealing Jupiter's dynamic atmosphere and its complex features. The spacecraft's findings included the discovery of two small rings around Jupiter and moons previously unknown, greatly expanding our knowledge of the gas giant. To ensure the spacecraft's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were executed. After the successful Saturn mission, researchers decided to conclude the planetary mission of both Voyager 1 and Voyager 2. However, the spacecraft were sent on new trajectories beyond the confines of our solar system, traveling at an astonishing speed of 325 million kilometers per year. In January 1990, the interstellar mission began, with Voyager 1 continuing its celestial journey. During this period, Voyager 1 made important discoveries, such as identifying 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most well-known images of all time. On February 14, 1990, Voyager 1, positioned approximately 6 billion kilometers from the Sun, embarked on a visual excursion known as the Family Portrait, capturing stunning images of the solar system's planets. This collection of 60 images added to the impressiveness of Voyager 1's portfolio of 67 photos taken during its encounter with Neptune. Voyager 2 also achieved remarkable milestones. As it got closer to Neptune, it recorded wind speeds exceeding 13,100 meters per second, the highest ever recorded in our solar system. This achievement provided invaluable insights into Neptune's distant atmosphere and its largest moon, Triton. Triton's surface, with temperatures dropping to minus 391 degrees Fahrenheit, is one of the coldest locations in our solar system. It exhibited unique features, including ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its hazy surroundings. These extraordinary findings enhanced our comprehension of the diverse and complex nature of celestial objects in the outermost regions of our solar system. The Voyager missions have delivered profound and transformative results. Voyager 1 and 2 discovered features on Jupiter and Saturn's moons once thought to be heavily scarred and inactive, but which turned out to be filled with geological activity. Voyager 2, in particular, achieved several historic milestones, including being the first spacecraft to fly by both Neptune and Uranus, and remains the only one to have done so. NASA employed various strategies to extend the life of these ambitious spacecraft, including shutting down non-essential heaters and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a touch of melancholy for the scientists and engineers who dedicated themselves to this extraordinary endeavor. The design of Voyager 1 and Voyager 2 was a marvel of engineering. These spacecraft were constructed as stable platforms rotating at a rate more than 15 times slower than a clock's hour hand. This design choice reduced visual blurring as the spacecraft traversed the vast expanse of space. Even before reaching the outer planets, the spacecraft began transmitting images of Jupiter, revealing its swirling clouds and iconic Great Red Spot, a massive storm that captivated audiences at NASA's Jet Propulsion Laboratory. However, the discovery of Io, one of Jupiter's moons with active volcanoes, attracted the most attention. The spacecraft's instruments detected unusual signals from Io, which were confirmed by unique images showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 10 times greater than that of Mount St. Helens, covering an area nearly the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power and memory before venturing into interstellar space. Notably, the images they captured did not include Mercury and Mars for various reasons. Besides the Voyager probes, NASA has launched other notable spacecraft, including Voyager 10, Voyager 11, and New Horizons. On February 17, 1998, Voyager 10 surpassed Voyager 11, becoming the farthest spacecraft from Earth. Despite the absence of other probes to observe it, Voyager 1 continued its solo journey for an additional 14 years before entering the interstellar environment on August 25, 2012. The Voyager missions were made possible through various innovative techniques, with gravity assist maneuvers standing out as particularly brilliant. These maneuvers were crucial for propelling the spacecraft to their distant destinations and collecting valuable data. The spacecraft relied not only on their own propulsion systems but also on gravity aids. Imagine the two fearless rockets gracefully navigating through our planetary system, utilizing the gravitational pull of planets to propel themselves forward. This celestial dance allowed them to conserve fuel and reach the necessary speeds to visit distant locations. A gravity maneuver requires precise timing, using a planet's energy as the spacecraft passes by. For example, as Voyager 1 approached Jupiter, the planet's significant gravitational attraction accelerated. As Voyager 1 continues its silent voyage through the vast expanse of interstellar space, its instruments, though aged, still function with surprising efficiency. Each data packet it transmits takes over 22 hours to reach Earth, traveling across more than 24 billion kilometers. These signals, though faint, carry insights from regions of space never before explored by human-made technology. The most recent anomaly detected in Voyager 1's telemetry has reignited global interest. Scientists at NASA's Jet Propulsion Laboratory are working around the clock to decode the strange data patterns. Initially dismissed as potential hardware degradation, the signals began to exhibit characteristics inconsistent with simple system errors. The repetition, structure, and timing of the transmissions led some experts to hypothesize the possibility of an external influence, perhaps even a new form of cosmic interference or interaction. Among the most intriguing theories is the idea that Voyager may first have passed through a region of space with unknown energetic properties, perhaps a dense interstellar cloud, a magnetic anomaly, or even a signal echo from a deep space source. Others have speculated about far more dramatic scenarios, including first contact with intelligent life. While NASA remains cautious, urging the public not to jump to conclusions, the excitement is palpable. Public interest in the Voyager mission has surged, with renewed discussions across scientific forums, podcasts, and social media. Documentaries and think pieces explore not only the spacecraft's legacy but also the philosophical implications of encountering something truly alien. If this anomaly is confirmed to be non-natural in origin, it would mark a turning point in human history, a validation of decades of speculation and a call to action for further deep space exploration. Meanwhile, Voyager 2, though on a slightly different trajectory, also continues to send data back to Earth. Though older systems have been deactivated to conserve power, it remains a vital asset in confirming or denying whether the anomaly detected by Voyager 1 is local to its path, or a broader interstellar phenomenon. Despite their age, both Voyager spacecraft stand as monuments to human curiosity, resilience, and the enduring desire to reach beyond what is known. With limited years left in their mission lifespans, every byte of data is more precious than ever. As we wait for clarity, one thing is certain: the story of Voyager is far from over. Whether the mystery unfolds into something terrestrial or transcendent, it continues to inspire a generation to look up, wonder, and ask, what lies beyond? Voyager 2 continues its missions beyond earthly bounds. Its accomplishments include flybys of Jupiter and its moons, Saturn and its moons, Uranus, and Neptune. Voyager 1's time-lapse images showcase 10 rotations of Jupiter in vivid detail, including the discovery of new moons and a small ring. These findings have substantially improved our understanding of Jupiter's complex system. Voyager 1 also discovered 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and took remarkable photographs of Saturn and its rings, offering fresh perspectives on Saturn's intricate system. The spacecraft also visited Uranus and Neptune, supplying useful details about their atmospheres and moons, enriching our understanding of the outermost regions of our solar system. After completing their planetary missions, Voyager 1 and Voyager 2 ventured into interstellar space, gathering data on the cosmic environment. This ongoing investigation continues to expand our knowledge of the universe beyond our solar system. As we await more information regarding the most recent Voyager 1 signals and their potential implications for our comprehension of the universe, the remarkable journey of these spacecraft remains a source of inspiration and enthusiasm for science and space enthusiasts alike. Their groundbreaking achievements continue to push the limits of human understanding and exploration, demonstrating the infinite potential of space discovery. The Voyager missions have provided a treasure chest of data regarding our solar system and beyond. Beyond the spacecraft's iconic images and scientific data, they also carried a golden record, a unique piece of art designed to convey the narrative of our planet to extraterrestrials. This record contains sounds and images chosen to portray the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds like thunder and whale songs. This message in a bottle, so to speak, reflects the hope that one day, if intelligent life exists elsewhere, they might locate it and comprehend it, providing a glimpse of humanity. Voyager 1 and Voyager 2 were, in essence, equipped with scientific instruments that have revolutionized our knowledge. These included magnetometers, plasma wave detectors, cosmic ray instruments, and imaging systems, each contributing crucial data about space phenomena. For instance, the magnetometers provided new perspectives on the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing complex interactions between these planets and their surrounding environments. The plasma wave detectors helped us understand the nature of the solar wind and its interaction with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that encloses our solar system. As Voyager 1 approached this boundary, it detected the sudden transition from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in shielding Earth from cosmic radiation. The spacecraft's observations have provided evidence of an identifiable boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally groundbreaking. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide important information about the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly notable for revealing its unique magnetic field, which is tilted significantly compared to the planet's rotation axis. This discovery challenged existing models of planetary magnetism and sparked additional research into the magnetic environments of other celestial bodies. In addition to their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, especially Io's volcanic activity, have captured the imagination of people around the world. These images have been featured in educational materials, documentaries, and popular media. The missions have fostered awe and a deep interest in the universe by emphasizing the significance of exploration and the quest for knowledge. The engineering and logistical feats achieved by the Voyager missions are also worth noting. The spacecraft were designed to operate in extreme conditions far from Earth, with temperatures below -220 degrees Celsius. They rely on radioisotope thermoelectric generators that generate and supply a consistent energy source, despite the vast distance from the Sun. Engineers faced numerous challenges, including ensuring that the instruments would remain functional for decades and that communication could be maintained over such immense distances. The data returned by the Voyagers has also influenced our comprehension of the larger cosmic environment. The spacecraft have helped map the location of cosmic rays and have provided information about the density and composition of interstellar dust. This information is critical for understanding the conditions in the space between stars and for preparing future missions that might explore other star systems. As the Voyagers continue their journey into space between the stars, their legacy is cemented not only by the data they have already provided, but also by the inspiration they offer for future research. These missions have paved the way for new technologies and methodologies in space science and have set a precedent for ambitious, long-term space missions. They demonstrate the potential of human creativity and the value of perseverance in the face of daunting challenges. Looking forward, the Voyager missions have sparked a new generation of spacecraft and mission concepts. Future probes aim to build upon the Voyager's success with the goal of exploring even more distant regions of the universe. These upcoming missions will continue to push the boundaries of our knowledge and will benefit from the foundations laid by the Voyager spacecraft. In conclusion, the Voyager missions represent one of humanity's greatest achievements in space investigation. Their contributions to science, their role in advancing our understanding of the solar system and beyond, and their impact on public imagination underscore the importance of continued exploration and curiosity. As Voyager 1 and Voyager 2 journey further into the cosmos, they remain enduring symbols of human aspiration and the endless quest for knowledge.